Application layer is a part of OSI. It is theoretical framework used to comprehend, describe, and understand each functionality and uses of application layer. And also, it describes how various networking protocols and technologies interact within a network. Let me discuss to you why OSI has a 7 layers. It is designed to scrutinize the data transmission, protocols, and the process. Each layers of application has a designated area or a specific area to perform by sending or receiving the data. It also provides the structure framework for comprehending and building network, communication system, and protocol. Let me illustrate the example of OSI model works. One of the most basic example of OSI model is peer-to-peer network model. It has two or more computers that are connected to one another and are able to share their resources. Example po nito is Bluetooth devices or Bluetooth. Ang Bluetooth po ay may tinatawag ding client or server. Ang example po nito ay si computer A, magkapasa siya ng file or data kay computer B, which means si computer A ang server and si computer B ang client. And it is one-to-one relationship. Pero meron po tayong tinatawag na one-to-many relationship. Ito po ay share it and easy share. Ginagamitan lang po siya ng hotspot and internet. TCP or IP has a 4 layer, which is network interface layer, internet layer, transport layers, and application layer. It was developed or created to be more practical and efficient model for the design and operation of internet and real networking.
So let us move on to the internet protocols. So ano nga ba yung mga internet protocols? Or ano nga ba yung meaning ng internet protocols? So internet protocol is like a digital navigation system that computers use to talk to each other on the internet. So it's a bit like how cars follow road signs and lanes to reach their destinations on a highway. So IP ensures that data packets, which are like parcels of information, find their way from your device to where they need to go online. So in other words, it's the essential rule book that keeps our online communication organized and ensures that your messages and data reach the right place smoothly, just like cars following traffic rules on a road. So after knowing the definition of protocol, let us now proceed with the different types of internet protocols, which are the DNS, HTTP, SMTP, and POP3. So for the first type of protocol, we have the DNS. So DNS stands for Domain Name System. It is a fundamental technology used on the internet that acts like a phone book for websites. So instead of remembering the numerical IP addresses of websites, just like the 192.168.1.1, DNS allows you to use human-readable domain names. So for example, the www.facebook.com. So it uses human-readable domain names in order for you to easily access the websites. So when you enter a URL in your web browser, DNS translates that domain name into the corresponding IP address, allowing your device to connect to the web server hosting the website that you want to visit. So DNS plays a crucial role in making the internet more user-friendly and accessible. So for the second type of protocol, we have HTTP. So HTTP means Hypertext Transfer Protocol, and it's the set of rules that allows your web browser to request and receive web pages and other stuff from the internet. So HTTP is like a language that your browser speaks to get web content. making the internet work for you. For the third type of protocol, we have SMTP and PAP3. SMTP stands for Simple Mail Transfer Protocol. Think of SMTP as the sender's post office. It is the system that sends your emails to others. So when you hit the send on your email, SMTP makes sure that it gets delivered to the recipient. So PAP3 stands for Post Office Protocol version 3. Now, PAP3 is like your mailbox at home. It is what you use to pick up your emails from the post office or your email server and read them on your computer or phone. It's all about receiving and storing your emails locally.
Client-server model. The client-server model is a networking architecture where one computer, or the client, requests services or resources from another computer, or the server, over a network. Client initiate requests and servers provide responses, typically in the form of data, application, or services. This model is commonly used in various computing scenarios such as web browsing, email, and many other network applications. It helps distribute processing tasks and resources efficiently in a network environment. Ang halimbawa nito is yung browser ang client na nagsasend ng request to the web page and the web server is the server. It listens for the request and returns the web page to the browser. Peer-to-peer network model. A peer-to-peer model is decentralized network architecture where participants in the network, called peers, interact directly with each other without the need for a central server or intermediary. In a P2P or peer-to-peer network, each peer can act as both a client and a server, sharing resources, data, or services with other peers. This model is commonly used for file sharing, communication applications, and distributed computing, as it offers benefits like robustness, scalability, and resistance to single points of failure. Example of peer-to-peer model is file sharing, instant messaging, share it, Bluetooth, and online gaming.
So for our next topic, we have the chapter 4, which is entitled OSI Transport Layer. The transport layer is one of the 7 layers in the OSI or the Open Systems Interconnection Model. It is a conceptual framework that standardizes the functions of a telecommunication or networking system. Its primary role is to facilitate communication and data exchange between two devices across a network. The transport layer helps devices communicate over a network. It does things like breaking data into smaller pieces for sending and putting them back together when received. It also checks for errors, manages data flow, and sends data to the right place. The transport layer has several important roles. The first one is the data segmentation. It breaks down large messages or data into smaller pieces for efficient transmission over the network. The second one is error detection and correction. It can detect errors in data transmission and, in some cases, correct those errors to ensure data integrity. The third one is the flow control. It manages the flow of data to prevent network congestion and ensures that data is sent at a rate the receiving device can handle. The fourth one is multiplexing and demultiplexing. It combines multiple data streams from different applications into a single network connection, multiplexing, and then separates them back to the correct destinations at the receiving end, demultiplexing. And the fifth one is port number assignment. It assigns port numbers to different applications or services so that data can be directed to the right program on a device. Overall, the transport layer plays a crucial role in reliable and efficient communication between devices on a network. So there are two popular transport layer protocols which includes TCP and UDP. So TCP stands for Transmission Control Protocol. So think of TCP like a responsible mail service for computers. It makes sure that when one computer sends a message to another, the message arrives safely and in the right order, just like your letters arrive at their destination without getting mixed up. It also checks for errors and controls the speed of sending messages to avoid overwhelming the receiver. It's the reason web pages, emails, and other online stuff work smoothly. On the other hand, UDP, which stands for User Datagram Protocol, is a way for computers to send information to each other quickly, but it doesn't make sure the information gets there perfectly. It's like sending a postcard, fast but not guaranteed to arrive or be read correctly. It's often used for things like video calls and online games where speed is more important than being perfect. So for you to better understand the difference between TCP and UDP, imagine this scenario. So TCP is like making a phone call. You say hello and make sure that the other person is ready to talk before you start your conversation. You also make sure that everything you say is heard correctly and in the right order. On the other hand, UDP is like sending a letter without calling first. You just send it, but you don't know if it arrived, and you don't know if it's read in the right order. It's faster, but not as certain as a phone call. So in summary, the main difference is that TCP creates a connection and guarantees reliable, ordered data delivery, while UDP doesn't establish a connection and offers faster, but potentially less reliable, data transmission. The choice between TCP and UDP depends on the specific needs of the application or service being used. So the next one is the transport layer port numbers. Port numbers are like labels for different services on your device. Here's why they're important. They help in finding the right service. They help direct data to the correct app or service running on your device. They help in running many services. Your device can run multiple apps at once, and port numbers ensure data goes to the right one. They help in making things easier. Port numbers follow standards, making it simpler to set up and fix networks. They help in staying safe. You can use port numbers to control what data is allowed in or out, which helps keep your device secure. And last one, they help in working efficiently. Port numbers help network protocols run smoothly. For example, they tell web browsers which door to knock on for a website. In short, port numbers are like addresses that makes sure data reaches the right place on your device and keep your network running well. The next one is the transport layer segments. In the transport layer of networking, data is divided into smaller units called segments. These segments are created to efficiently transmit data across a network. Here's a simple explanation. Imagine you have a big chocolate bar. Instead of sending the entire bar at once, you break it into smaller pieces called segments. These segments are easier to handle and can be sent one by one. Once they reach their destination, they are put back together to recreate the original chocolate bar. In networking, data is like the chocolate bar, and the transport layer breaks it into segments for smoother and more efficient transmission.
TCP, or Transmission Control Protocol, is a reliable transport protocol as it establishes a connection before sending any data, and everything that it sends is acknowledged by the receiver. In this lesson, we will take a closer look at the TCP header and its different fields. One field of header is the source port number. It specifies the application sending the segment. This is different from the IP address, which specifies an internet address. The second field of header is the destination port. It defines the receiving application port numbers below 1023 called well-known ports are assigned to commonly used application. The third field is sequence number. Each bit in the stream that TCP sends is numbered. Next field is acknowledgement number. This field identifies the sequence number of the next data by that the sender expects to receive if the acknowledged bit is a set. Header length. It specifies the length of the TCP header in 32-bit words. Reserve. This field is reserved for future use and must be set to 0. The next field is the flags. There are 9 bits for flags. We also call them control bits. We use them to establish connections, send data, and terminate connections. Napapaloob dito sa flag is yung URG, which is urgent pointer. When this bit is a set, the data should be treated as priority over other data. The next is ACK, or the acknowledgement. The next is PSH. This is the push function. This tells an application that the data should be transmitted immediately and that we don't want to wait to fill the entire TCP segment. The next is RST. This resets the connection. When you receive this, you have to terminate the connection right away. This only used when there are unrecoverable errors and it's not a normal way to finish the TCP connection. Next is SYN. We use this for the initial three-way handshake, and it is used to set the initial sequence number. And the last is FIN. This finish bit is used to end the TCP connection. TCP is pulled up flex, so both parties will have to use the FIN bit to end the connection. This is the normal method how we end a connection. So let's move on to the other field. The next is window size. It specifies the number of bytes the receiver is willing to accept. This field can be used to control the flow of the data and congest. The next layer is the checksum. It is used for transport layer error detection. The next field is the urgent pointer. If the URG flag bit is set, the segment contains urgent data, meaning the receiving TCP entity must be deliver it to the higher layers immediately. Next is options. Size of this field is variable option. Field may be used to provide other functions that are not covered by the header. The last is data. Data field size is variable. It contains user data. Nilalagyan lang ng data if meron. Pag wala, hindi na siya nilalagyan ng data. And that's all for the TCP header. What is port numbers in communication? Port numbers are used in computer networking to distinguish different services or applications running on the same device. They are a part of the transport layer of the Internet Protocol suite. Port numbers range from 0 to 65,535 and are divided into 3 categories. The first is well-known ports, or 0 to 1023. These are reserved for widely used services. The next is registered ports, 1024 to 49,151. These are assigned to specific applications or services by the Internet Assigned Numbers Authority. The third is dynamic or private ports, 49,152 to 65,535. These are available for use by any applications or service but are typically chosen by the operating system for outgoing connections. Port numbers help ensure that data arriving at device is directed to the correct application or service. TCP three-way handshake is a fundamental process used to establish a connection between two devices in a TCP or IP network. It ensures that both the sender and receiver are ready to exchange data and that they agree on certain parameters for the communication. The three-way handshake works. First is syn or synchronized. Second is syn-ack or synchronized acknowledge. And the last is ack or acknowledge. The three-way handshake ensures that both devices are ready and agree on initial sequence number before data transmissions begin. It also helps in error detection and ensures that both sides are aware of each other's readiness to communicate. Ano nga ba ang TCP termination? Ang TCP termination process is often referred to as the TCP four-way handshake. It is used to gracefully close a TCP connection between two devices. It ensures that both sides have finished sending and receiving data before the connection is fully terminated. The TCP terminations four-way handshake. First, initiator sends fin or finish. Second is acknowledgement. The third is receiver sends fin. The fourth is acknowledgement again. After that, the TCP connection is fully terminated. Both devices have signaled their intent to close and they have acknowledged each other's request for termination. This four-way handshake ensures that data is not lost in transit and that both sides are in sync regarding the connection's termination.
Reconstructing TCP data stream. Ito po yung tumutulong to reassemble the out of order of TCP or the data. Sila rin po yung nag-group ng bytes tsaka nagre-rearrange ng data sa TCP segment in order to pass the IP address for transmission to the destination or to the user. Ang TCP po ay may presentation of bytes or nagpe-present sila ng bytes dapat hindi nag-exceed sa limit ng TCP. Halimbawa po ay sa TCP, kung ang kanya pong bytes is 32, dapat hindi po siya lalampas sa 32 para maiwasan po yung crashing at saka lagging po ng isang system. Managing TCP session, it is to maintain the stable response for network and infrastructure and different network devices and protocols to ensure optimal performance and reliability. Ang una po is, halimbawa po ay establishing connection. Ang unang-una po is establish connection to make the transport service reliable, efficient, and effective. And also, TCP hosts must establish a connection-oriented session to one another. Gumagamit din po sila ng three-way handshake mechanism. Nandun po yung synchronize and acknowledge sa data para mag-establish po ng connection between server and client. Flow control TCP session, sila po yung nag-ensure sa ating data flow between sender and receiver. Sila rin po yung namamahala upang maiwasan yung data duplication and data redundancy. It's maintaining the communication between devices over a network and also allow for the efficient utilization and preventing data loss. TCP transmission is all about balancing the receiver and sender. They manage the rate of data transmission between sender and receiver. They also manage the window size that represent how many bytes it's willing to accept in the given time. Ang example po nito ay pag tayo magte-text, meron po siyang capacity. Kung ilang bytes lang po yung pwede sa isang text message o sa isang data para po maiwasan yung lagging and crashing ng isang system po. UDP or User Datagram Protocol is a lightweight protocol that has no delay for connection establishment and also there have no allocation of buffer and parameter sequence sa data. Napakadali po na rin i-handle sa mga iba't ibang active clients. It also maintaining the balance between sender and receiver to make it accurate the information by to one another.
So now let's talk about the chapter 5, which is the OSI network layer. The network layer is a crucial component of the OSI or Open System Interconnection Model and the TCP or IP protocol suite, both of which are fundamental frameworks for understanding and implementing computer networking. The primary functions of the network layer is to facilitate end-to-end communication across a network by routing data packets from the source to the destination. The network layer or OSI layer 3 provides services to exchange the individual pieces of data over the network between identified end devices. To accomplish this end-to-end transport, layer 3 uses four basic processes: addressing, encapsulation, routing, decapsulation. Addressing. First, the network layer must provide a mechanism for addressing these end devices. If individual pieces of data are to be directed to an end device, that device must have a unique address. In an IPv4 network, when this address is added to a device, the device is then referred to it to as a host. Encapsulation. The term encapsulation is used to describe a process of adding headers and trailers around some data. Ang example nito is when you send an email using your favorite email program like Outlook, the email is sent from the application layer to the transport layer. The transport layer encapsulates the data and adds its own header and passes the data to the internet layer, which again encapsulates the received data and adds its own header, usually with information about the source and destination IP addresses. The internet layer then passes the data to the network access layer. This layer is the only layer that adds both a header and a trailer. The data is then sent through a physical network link. Routing is a critical process in computer networking that involves determining the path that data packets should take to reach their destinations across a network. It's a fundamental function performed by devices known as routers. Routing ensures that data packets are forwarded efficiently and reliably from the sources to the destination. Decapsulation, in the context of networking and data communication, refers to the process of removing the headers or encapsulations added to a data packet at each layer of the OSI model or the TCP or IP protocol suite as the packet travels through the network. It is essentially the reverse process of encapsulation, which involves adding headers at each layer as data moves from higher to lower layers. Application layer, transport layer, network layer, data link layer, and physical layer. Network layer protocols. Protocols implemented at the network layer that carry user data include Internet Protocol version 4, Internet Protocol version 6, Novel Internet Work Packet Exchange, Apple Talk, Connectionless Network Service. The Internet Protocol version 4 and version 6 is the most widely used layer data carrying protocol. What is IPv4? IP stands for Internet Protocol and V4 stands for version 4. IPv4 was the primary version brought into action for production within the ARPANET in 1983. IP version 4 addresses are 32-bit integers which will be expressed in decimal notation. Example is 192.0.2.126 could be an IP version 4 address. Ang IPv4 ito yung pinagbabatayan ng teknolohiya na ginagawang posible para sa atin ang i-connecta ang ating mga device sa web. IP version 4 Basic Characteristics. Connectionless. No connection is established before sending data packets. Best efforts are unreliable. No overhead is used to guarantee packet delivery. Media independent. Operates independently of the medium carrying the data.
IPv4 protocol. It was designed as a protocol with a low overhead. It provides only the functions that are necessary to deliver a packet for a source to a destination over interconnected system of a network. So we have three basic elements of IP packets or flow through the internet network. We have connectionless, best effort, and media independent. Connectionless is established before sending the packet, while best effort or unreliable is overhead used to guarantee packet are delivered. Media independent is operate independently of the medium carrying the data. IPv4 packet header. The type of service that we have is this is used for the quality of service. There are 8 bits that we can use to mark the packet, so which we can use to give the packet a certain treatment. The total length of the packet header is 16-bit field indicates that the enter size of the IP packet is the minimum size of 20 bytes. so that the maximum size of the total length of packet header is 65.53 bytes. Yun na po yung highest value that we can create as 16 bits. Sa pag-identify naman po ng packet header, we have a fragment, then each fragmented packet that we'll use in the same 16-bit identification number to identify every packet that they belong to. Have a key IPv4 header. IPv4 header format is 20 to 60 bytes in length, contains information essential to routing and deliver, consisting of 13 fields. The version is 4 bits version indicator. In case of IPv4, the value of 4-bit is set to 0100, which indicate in the 4 in binary. Ang type of service naman po ng ating header fields is called Differentiated Service Code Point or DSCP. Ang field po nito is to provide features related to service quality, such as for a data streaming or voice over. It is used to specify how datagram will be handled. Dividing network, it is help to manage the division of network and to manage the group of hosts into a specific network. Ang example po nito ay when the network grow, they become too large to manage to a single network. Kaya po nagkaroon tayo ng dividing network is to hold the information para po hindi magkaroon ng complexity sa data. Kasi po sa pagdami ng data, sa paggulot, hindi na po doon nalalaman kung ano pa yung reliable and accurate information. Kaya po nagkakaroon po tayo ng dividing network. Ang grouping host po ay meron po siyang iba't ibang function and separate network to improve network management and operation. They hold the data or the information in order for us to identify kung sino po yung receiver or sender ng isang data or information. To manage and address the network, we have performance degradation, security issue, and address management. Napaka-importante po nito, kaya po nagkakaroon ng hiwalay na host at saka network in order for us to save the information and data. Kasi po sa pagdami ng data, hindi na po doon nalalaman kung ano po yung reliable and accurate information.
So for the next one, we have routing. Routing in the network layer is like finding the best way for information to travel through a network of computers. It's like GPS for data. GPS for data. Think of routers as GPS devices for data. They figure out the best route for information, like emails or web pages, to go from one place to another on the internet. Updating directions. Routers talk to each other and update their directions regularly. If a road or network connection gets blocked, they find a new way to send data. In short, routing is about guiding data through the network, making sure it gets to the right place quickly and reliably. Next one is the IP packets. IP, or the Internet Protocol packets, are fundamental units of data used for communication over the Internet and most computer networks. They contain both the data being transmitted and information needed for routing that data to its destination. IP packets are the building blocks of data transmission on the Internet, allowing devices to communicate with each other across networks. They are processed by routers and switches, which use the information in the packet headers to determine where to send the packet next on its journey to its destination. Think of IP packets as digital envelopes for sending information over the Internet. These envelopes have addresses, contents, instructions, quality check, and type of content. These IP packets help computers talk to each other on the Internet by carrying data and instructions. Routers and computers read the envelope to know where to send it next until it reaches its destination. Next one is the gateway. A gateway is like a digital bridge or translator that connects two different networks, allowing them to communicate with each other. A gateway is a connection point between two networks, acting as a bridge and translator, and often providing security measures to ensure smooth and safe communication between them. Next one is the route. A route is the path or way to get from one place to another. In the context of computer networks on the internet, it's like finding the best road for data to travel from one device to another. Just like you might use a map for directions, computer networks use routes to send data efficiently and accurately. The next one is a host routing table. A host routing table, often simply called a routing table, is like a map that a computer or device uses to figure out how to send data to other devices on a network or the internet. It contains a list of destinations and the paths or routes to reach them. When your computer wants to send data to another device, it checks this table to decide where to send the data. Next is the destination network. It is like a specific neighborhood or area in a city that you want to send something to. In computer networking, it refers to a particular group of devices or computers on a network that share a common part of their IP addresses. Next is the next hop. It is like the next step or the next stop for data on its journey through a network. In networking, it refers to the immediate destination, router, or device that data packets should be forwarded to in order to reach their final destination. Next is the packet forwarding. Packet forwarding is like the mail delivery service for data on a computer network. Packet forwarding is crucial for data to move efficiently and reliably across computer networks, whether it's the internet, a local network, or any other digital communication system. Packet forwarding is all about making sure your digital information gets where it needs to go, piece by piece. And the last one is the routing processes. Routing processes are like traffic rules for data on a network. They determine how data should travel from one place to another. Routing processes are like the GPS for data on the internet. They figure out the best way for data to go from one place to another. Think of data as delivery packages. Routing processes are like GPS directions showing data where to go. Routers are like traffic controllers. They use the GPS directions to send data in the right direction. The goal is to make sure data reaches its destination quickly and safely. So, routing processes are like digital GPS guides for data, ensuring it gets where it needs to go on the internet.